Evening. I'm Spot On Weather meteorologist Matthew Euler. Tonight, I'm taking a look at past El Nino analog years and then the temperature regimes for the following winters across the United States. So, my overall goal in the research I conducted was to look at past Julys, which featured El Nino conditions, and then I examined the following winters, the temperature regimes, how far above or below normal those temperature regimes were in the specific focus on the eastern United States the following winter. Now, winter is considered to be December, January, and February. So let's take a look at the interesting research that I came up with. The overview, first and foremost, in today's video, I decided again to take a look at past years with El Nino conditions during the month of July. And we're currently sitting in that situation here in the year 2023. Presently, the sea surface temperature departures from normal in that Nino 3.4 region during the month of July varied greatly. I'll break down these types of the strength of these El Ninos. My research goes back to the year 1982, by the way, as well. But there was a wide array of intensity differences for El Nino conditions in the month of July, ranging from a weak El Nino to a moderate El Nino to a strong El Nino, as well as very strong El Nino criteria. And again, I'll break those down here shortly. Now, in addition to sea surface temperature departures from normal in that Nino 3.4 region, I also spatially examined the overall global sea surface temperature departures from normal, where those areas of above and below normal water temperatures or sea surface temperatures were across the Pacific Ocean. My main focus in this research was on the Pacific Ocean, being that the United States resides in that westerly wind belt, and with the weather traveling from west to east and the Pacific Ocean having such a profound influence on the United States weather, I really focused on those global sea surface temperature departures or anomalies across that area. Further examination, I also investigated air temperature anomalies the following winter season. So this is the overall research and why I conducted this research. I was looking at, again, the past Julys that had El Nino conditions, varying in strength from weak to very strong. And then I looked at the following winter, the months of December, January, and February. And this video just focuses in on temperature anomalies or departures from normal during the following winter. So let's first break down what I discovered. Again, this data goes back to 1982. So these are all the months of July going back from the present time. I did not put July of 2023 where we're sitting now. I basically went and looked at all the other El Nino conditions in the month of July for the years 1982, for the year 1987, for the year 1991, 1997, 2002, 2004, 2009, and 2015. So I have a sample size of 8 total Julys going back to 1982 that met the requirement or criteria for El Nino conditions, which basically means your sea surface temperature anomalies in that Nino 3.4 region were at 0.5 degrees Celsius above normal or greater. And again, you can see the wide array of anomaly differences here from year to year, all the years I'm examining here for the month of July. So July 1982, we had a 0.8 to 1.1 degrees Celsius above normal sea surface temperature anomaly in the Nino 3.4 region. For July of 1987, it was quite a strong El Nino condition for that July, ranging from 1.5 to 1.7 degrees Celsius above normal in that Nino 3.4 region. July 91, sitting at 0.7 degrees Celsius sea surface temperature anomaly in the Nino 3.4 region. July 97, another strong El Nino in the month of July back in the year 97. And of course, I'll get to that winter of 97, 98 as we go through the slides. Pretty impressive El Nino winter there. But already in the month of July back in 97, we already saw anomalies on the order of 1.6 to 1.9 degrees Celsius above normal. July of 2002, zero 0.8 to 0.9 degrees Celsius sea surface temperature anomaly in Nino 3.4 region. In July of 2004, we saw a 0.5 to 0.6 degrees Celsius above normal sea surface temperature anomaly in Nino 3.4 region. In July 2009, 0.5 to 0.6, very similar to 04 in the month of July. We saw a sea surface temperature anomaly above normal water in Nino 3.4 region. And then going back as recent as July 2015, another strong El Nino situation in the month of July, 1.5 to 1.9 degrees Celsius above normal sea surface temperatures in the Nino 3.4 region. And 2015-2016 winter was just as impressive as the 97-98 winter. And again, I'll get to that here in a moment. So this kind of lays the groundwork for the various Julys. And I look back at the Climate Prediction Center website. I look back to look and to see what those anomalies were using their archive of ENSO. So now let's examine, the first thing I want to examine in the research is what the spatial distribution of the sea surface temperature anomalies look like in the Julys, which I just examined these years. 82, 87, 91, 97, 2002, 2004, 2009, and 2015. I'm now going to look individually at the spatial distribution of the above and below normal sea surface temperature anomalies across, the main focus is across the Pacific Ocean basin here, this North Pacific area, okay, and down to the equatorial Pacific, of course, where El Nino occurs. All right, so July 82, look how much below normal, the blue coloring indicating below normal sea surface temperatures, and the yellow coloring indicating above normal sea surface temperatures, and you can see the scales here on this horizontal axis at the bottom, showing you how much above or below these waters were. So in July of 82, we can see the El Nino conditions off the west coast of South America. And additionally, up here off the coast of British Columbia and the Gulf of Alaska, off the coast of Baja and California, we had below normal temperatures, sea surface temperatures going on in July of 82. This basically resulted in a weak to moderate El Nino in July of 82. July of 87, what did the sea surface temperature anomalies look like across the Pacific? We had a pretty significant negative anomaly here, colder than normal, across parts of the north central Pacific. Another little pocket of below normal water temperatures there off Southern California, off Baja. We had a very well pronounced El Nino going on in July of 87 already, and you're seeing some of these values here. Look how far west these warmer than normal waters extended, all the way from the west coast of South America to the central Pacific. Let's take a look at July 1991 now, a little bit different. We do see the warming, the yellow coloring here, indicating above normal waters again across the eastern and central portions of the equatorial Pacific, indicating the El Nino conditions. We did have a below normal area of water right along the west coast of Canada, working our way southward along the west coast of the United States. Also off of Baja once more. We did see an above normal pocket of water here across the north central Pacific, indicated by the yellow color here to the west of the North American continent. And then July of 97, how did things turn out as far as sea surface temperature anomalies in July 97? Across the Pacific, look how strong in July 97 the El Nino already was. I mean, you're looking at 3.5, 3.6 degrees Celsius above normal waters off the immediate coast there of South America, off of Peru. Wow. And look how far west these anomalously warm waters extended in July of 97. So El Nino was well established in 97 in the month of July. We also saw some warmer pockets of water in the Gulf of Alaska, off of British Columbia, working our way down off the U.S. West Coast, off Baja, we have above normal waters. There was a little bit of below normal water there across the northwestern Pacific, east of Japan. What about July 2002, sea surface temperature anomalies? And oh, by the way, again, you can kind of read this as I go through this, but I forgot to mention. So we had weak to moderate El Nino criteria in July of 82, based on the sea surface temperature anomalies across that Nino 3.4 region. In July of 1987, we saw a strong El Nino that developed. By July of 91, we saw a weak El Nino. And then in July 97, which I just covered, it was a strong El Nino already established. Looking at July 2002 now, we see fairly normal, near normal, whenever it's white coloring that indicates near normal waters. This did technically meet El Nino because we did have some warming here in that Nino 3.4 region. But the warmer than normal waters were generally over the central equatorial Pacific, vice the eastern. And then we saw below normal water temperatures extending southwestward towards the big island of Hawaii, 0.5 to 1 degree Celsius below normal waters here off of Southern California, Baja in July of 2002. We saw below normal waters as well across the north central Pacific. And then just to the southwest of that, we saw above normal waters slightly there across the central Pacific. This was a weak El Nino. The conditions were weak El Nino criteria in July of 2002. Now, July 2004, we see actually a little bit cooler than normal waters here off the coast of South America. But in that Nino 3.4 region, which we used to basically classify El Nino or La Nina conditions, we saw a little bit of above normal waters in that Nino 3.4 region across the equatorial central Pacific. Additionally, we had a pretty impressive area in July 2004 of above normal waters. Gulf of Alaska extending southward off of western Canada and off the west coast of the United States. A couple pockets of below and then above normal waters across the north central Pacific. Looking at July 2009, we had a weak El Nino. In July of 2009, we saw below normal waters, generally extending from the west coast of Canada, working our way southward off of the west coast of the United States, 0.5 to 1 degree Celsius below normal waters. We did see an above normal water pocket basically northwest of the Hawaiian Islands, as well as to the northeast of that area. And then you can see the yellow shading here, the above normal sea surface temperature anomalies off the west coast of South America, extending westward towards the central equatorial Pacific, about 0.5. In the eastern Pacific, equatorial Pacific here, it's about 1 degree Celsius above normal waters. Looking at July 2015 sea surface temperature anomalies, we were in the midst of a strong El Nino in July of 2015. And look at these water temperatures, how much above normal they are. Very much above normal. This was more of an east-based El Nino at the time, closer to the coast, west coast of South America. But look how far west, again, these anomalously warm waters extend from 1 to 1.5 to 2 degrees Celsius above normal. And look at the whole eastern North Pacific that particular month of July 2015. Well above normal into the Gulf of Alaska, well above normal off the U.S. West Coast. There was one pocket of below normal readings extending across the North Central Pacific, and then just to the southwest of that, there were some below normal water temperatures. But this is really impressive. And if you look at July 2015 and you compare it to July of 97, all right, we saw July 97. This was outrageous how much above normal the waters were there in the eastern equatorial Pacific, 3.5 degrees Celsius. But the overall placement of the warmer than normal waters is very similar between July of 97 during that strong El Nino and July of 2015. Now, let's take a look at the current sea surface temperature anomalies. This is effective as of today, the 28th of July, 2023. And look at what we got here. We have an above normal area off the west coast of Canada, off the west coast, the Pacific Northwest coast of the United States, extending southwestward. This is a marine heat wave that's going on, anomalously warm waters here. And just to the southeast of that, off the coast of Southern California, Baja, extending southwestward, just to the southeast of the Hawaiian Islands, we have slightly below normal water temperatures indicated by the blue shading. Off the coast here, South America, look what we got. Well above normal water temperatures. That's in association with the current El Nino conditions we're experiencing. And look how far west this orange shading goes, all the way back to the central portions of the equatorial Pacific. Over across off the coast of Japan, whether we're looking at west of Japan or east of Japan, it's well above normal water temperatures going on at the present time. Now let's take a look at the July 2023, the current sea surface temperature anomalies in that Nino 3.4 region specifically. And right now the value is sitting at plus or 0.939 degrees Celsius above normal in the Nino 3.4 region. So right now, the criteria, the strength classifications, a weak El Nino occurs when the waters are zero point 0.5 to 0.9 degrees Celsius above normal. And we're heading closer and closer to moderate strength, which is 1 to 1.4 degrees Celsius above normal water temperatures in this Nino 3.4 region. And so, good comparisons to today. So I took a look at the past spatial distribution of the sea surface temperature anomalies with a focus on the Pacific Ocean basin. Then I compared it to the current sea surface temperature anomalies, as well as the current Nino 3.4 region values, how much above normal we're sitting here in El Nino conditions in July 2023. Now, let's take a look at the following winters out of all the Julys in which I've shown you had El Nino conditions. What did the following winters hold as far as temperature anomalies? Blue and green shading on these maps indicate below normal temperature readings, whereas the orange and the brighter brown, like this brighter maroon color and the brown, indicates well above normal air temperatures. We're talking air temperatures here, okay? So, winter again is classified in this research from the months of December through February. And then I start each one of these slides with the month of December on the left, January in the middle, and February on the right. So first, let's take a look at December 1982 to February 83, what those mean air temperature anomalies look like. So after a milder December in the east, December 82 here, conditions, as you can see, became more El Nino-like with below normal temps. Generally here in January in the middle, that blue and green shading, we had below normal air temperatures in January of 83 to the south up to the mid-Atlantic. And then we also had below normal readings, air temperature readings, across the southern U.S. up to the mid-Atlantic in February of 83, okay? This was, by the way, this particular winter turned out to be a very strong El Nino. What do I mean by very strong? Sea surface temperature anomalies in that Nino 3.4 region exceeded 2 degrees Celsius above normal. Looking at December 87 to February 1988, this 87-88 winter, note here on the left in December 87, it was another mild start for the eastern U.S., the mildest temperatures were across the Dakotas and northern Minnesota, the northern plain states. But by the time we got to January of 88 and then February of 88 here on the right, notice that green shading and even the purples here. Most of the United States in January of 88 was shivering well below normal with the temperatures. And then we got to February 88 here on the right. Notice the coldest temperatures in the upper Midwest, right on down to just the Missouri Valley, as well as the Midwest in general. But we saw a colder than normal January in 88 and as well as February 88. Most of the coldest temps were focused or centered east of the Rocky Mountains by the time we got to February of 88. And by the way, the December 87 to February 88, that 87-88 winter was classified as a weak to moderate El Nino. What about the winter of 91-92? December 91 over here on the left, showing that overall it was a mild regime for temperatures in the winter for the eastern U.S., specifically up here in the northern plains. Montana and the Dakotas really were warm that winter, 91-92. Most of these locations are colder. That's generally where the coldest air is coming from Canada in the United States. And upstream of the East Coast, you're seeing these anomalously warmer than normal readings. Overall, very mild winter. We had a strong El Nino. We had a strong El Nino in 91-92 winter. Now, December 97 to February 98, we're taking a look now at the mean air temperature anomalies for the winter of 97-98. This was a very strong El Nino winter. Okay, this is the second very strong El Nino winter I'm going to talk about. We already looked at 82-83. Now we're in 97-98 with similar situation. December 97 over here on the left, this started off like a typical El Nino winter where you get the coldest temperatures further south, okay, and the warmest temperatures further north. This is a normal looking El Nino winter as far as the temperature anomalies go. But by the time we got to January of 98 and then definitely February 98, look at this. This is a very warm conditions, very warm across the east in January of 98, and then look at this on the far right in February 98. Oh, wow. Upper Midwest is just well above normal at this point. Again, this is a very strong El Nino. So looked like El Nino in December and turned out to not act like El Nino in January of 98 and February of 98. Looking at December 02 to February 03. So now we're looking at the winter of 02 and 03, the 02-03 winter. Mean air temperature anomalies. All right. This was a fairly cold winter across the eastern United States as a whole. This is December of 2002 on the left. And look at where your coldest temperatures were, from Florida all the way up the East Coast to Maine. That was December of 02. By the time we got to January of 03, 2003, look how much the U.S., there was a dividing line here across the Rockies, right here on the eastern edge of the Rockies. Anything west of the Rockies was well above normal across the western U.S. in January of 03. Anything east of the Rockies, especially towards the East Coast and New England, was well below normal. Over here on the right is February of 03, again, well below normal east of the Rockies. So we had 2 straight months in the winter of 02-03 in which we saw well below normal air temperatures eastern U.S. And this was a moderate El Nino winter, okay? Looking at the winter of 04-05, December started off very much looking like El Nino winter. We had below normal readings across South Texas, Louisiana, the Gulf Coast, Florida, and then working their way up into the mid-Atlantic, even up into New England in December 04, the temperatures were below normal. The warmest readings were out in the northern plains of the Pacific Northwest, which you would expect during El Nino winter. What happened over time is the milder or warmer than normal temperatures expanded to the Tennessee Valley all the way to the mid-Atlantic. And then definitely by February 05, look at this, it's a torch. Well above normal temperatures across Montana, Dakotas, Nebraska, Iowa, Minnesota, Wisconsin, and Illinois. Near normal along the immediate Atlantic coast, mid-Atlantic coastline here. This, by the way, was a weak El Nino winter. Now let's look at 09-10. This was the winter of 2009-2010. Now this was a very interesting winter, okay? First of all, December 2009 got off to a crazy, crazy below normal situation across all the United States. Do you see any orange above normal readings across the United States in December 09? No, you don't. And it was just frigid across Montana, the western Dakotas, as well as Nebraska in that particular December. And then look at January of 2010. It's not changed much. The coldest readings, if anything, have slid a little further to the southeast across the Missouri Valley, as well as the southeastern U.S. and Florida. And then look at this, February 2010. Look how much below normal this purple shading things are. We're talking 9 to 11 degrees below normal, 9 to 11 degrees Fahrenheit below normal across the Gulf Coast states in February 2010. So this was an anomalously cold winter for the eastern U.S. That's what I'm getting at. Much below normal for the entire U.S. in December on the left, and then remaining below normal for the southern and eastern U.S. right on through January and February. Now this was a strong El Nino year. Strong El Nino winter. And then 2015-16, I believe that's the last one I'm going to examine yet. This winter, 2015-16 winter, December to February, this was insane. December 2015 was just insane with how much above normal in this brown shading, such widespread above normal readings in December. That brown shading generally indicating temperatures in excess of 11 degrees Fahrenheit above normal for all of this brown area, east of the Mississippi River. Right onto the East Coast, up to New England, down to Florida. It was extremely mild. This was a very strong El Nino winter, right? So that is the third one, right? 82-83, 97-98, and now 2015-16. Some people are comparing the upcoming 23-24 winter could potentially rival this kind of strength of El Nino. We'll see. Now over here in the middle is January 2016 air temperature anomalies, and look, it kind of switched around here briefly in the mid-Atlantic down to the southeast. Actually got cooler than normal. Not super cold, but cooler than normal nonetheless by a little bit. We're talking 4 to 5 degrees Fahrenheit in this green shading here across West Virginia down into the Asheville, North Carolina area, into the eastern Tennessee area and southern Kentucky. By the time we got to February 2016, winter was over. So no winter in December of 15. Winter somewhat showed up in January of 16, and then it went back basically to no winter again. Look how much of the United States in February of 2016 was actually above normal, including the northern plains again. Very strong El Nino year. So the results from the research, here we go, let's break it down. 8 total July months met the El Nino criteria, going back to the year, took this data back to the year 1982. So what's that, a little over 40 years of data? Now, of the 8 total El Ninos in July, here's the breakdown. In the month of July, we saw 4 weak El Ninos, 91, 2002, 04, and then also 2009. There was 1 moderate El Nino back in July 82. There were 3 strong El Ninos in July 87, July 1997, and July 2015. And when you know it, we already had strong El Ninos going on in the months of July in both 97 and 2015. And remember what those winters look like. They featured very strong El Ninos, 97-98 winter and 2015-16 winter. And that means, again, very strong El Ninos, those sea surface temperature anomalies, those waters are in excess of 2 degrees Celsius above normal in the Nino 3.4 region. So I find this really interesting, right? Very interesting. Now, the other very strong El Nino winter, the 82-83 winter, had moderate El Nino conditions during the month of July. Now, after the July El Nino conditions were met in these years right here that I just went over, the following winters exhibited 3 very strong El Ninos. Again, those very strong El Nino winters were 82-83, 97-98, and 2015-16. We saw 2 strong El Nino winters, 91-92, as well as 2009-2010. And then 2 moderate El Ninos, 1987-88 and 2002-03. And then we saw 1 weak El Nino winter in 2004-2005. So I looked at the strength. We had 8 total El Nino conditions met, 8 total Julys, which El Nino conditions were met back to 1982. I broke the 8 total El Nino conditions in July down into various strengths, weak, moderate, strong. Okay. And then I looked at the July, after the July El Nino conditions were met in these years in bullet 2, I went and looked at what the following winter, how the El Nino changed between July and the following winter. What I discovered was that the coldest winters occurred in the years that winter of 1987-88, and we had a strong July El Nino before this happened. So, interesting, right? We have 3 strong El Nino conditions that were met in the month of July, right? I already talked about 97 and 2015, all right? Those following winters featured a very strong El Nino and quite mild winters, actually, across the East, 97, 98, 2015, 16. But just because you have a strong El Nino in July does not necessarily mean you can't get a cold winter across the East. And that's really what I'm getting at here. We had a strong July El Nino in 1987, but we had a colder than normal winter in the eastern U.S., the winter of 87-88. 2002-2003 winter featured another below normal winter across the East in 2002-2003, and we had a weak July El Nino. And the winter of 2009-10, we also had a weak July El Nino. So, out of the coldest winters I have examined, okay, going back to 1982, 2 of the 3 featured a weak El Nino in July. Only 1 of the 3, or a third, featured a strong El Nino in the month of July, and that was the July 87, had a strong El Nino going on. But it featured a colder than normal winter in the East, in the winter of 87-88. Now, the warmest winters occurred in the years 91-92, and we had a weak July El Nino before that particular winter. 97-98, we had a very warm winter across the eastern U.S., and that featured a stronger July El Nino. In 2004-2005, also very warm, above normal temperatures across the eastern U.S., in which there was a weak July El Nino. And then 2015-16, we saw a strong July El Nino before that winter. And that December was just, like I said, it was ridiculously warm. So here's my conclusion based on what I looked at in the research. The July global sea surface temperature anomaly distributions across the Pacific, that's my focus, right? Where were the above normal areas and below normal areas for the sea surface temperatures, okay? And then I also looked at the magnitude of those Nino 3.4 water temperature departures. Okay, so just based on the spatial distribution across the Pacific Ocean, the North Pacific, of those, sea surface temperature anomalies, just on that spatial distribution, I found that this year, July of 2023, the analog years are very similar. The analog is very similar to July of 91, what we saw as far as this global sea surface temperature anomaly spatial distribution in the Pacific, and July 2004. Those are the two Julys that come close, 91 and 2004. Now, if I look at just the Nino 3.4 water temperature anomalies, those magnitudes, how much above normal those temperatures were, July of 82 and July 2002 come closest to this current year, July 2023. And in those years, July of 82 and July of 2002, the range of above normal water temperatures in that Nino 3.4 region was 0.8 to 1.1 degrees Celsius. So, therefore, taking into account these two factors, okay, the closest analog years as of right now, July 28th, 2023, are 1982, 1991, 2002, and 2004. Now, again, these only take into account these two things: spatial distribution of sea surface temperature anomalies across the North Pacific down to the equator, of course, with El Nino, and then also those Nino 3.4 water temperature departures from normal. That's it. That's all I'm taking into account. Okay. Now, factoring in the past winter El Nino strengths, which we already took a look at, the 82-83 winter had a very strong El Nino. The 91-92 winter, a strong El Nino. 2002-2003 moderate El Nino, and 2004-2005 weak El Nino. And then the upcoming forecast for the 23-24 winter season coming up here, 2023-2024 winter, is the forecast. The models are showing a strong El Nino is forecasted for the upcoming winter. If I take that into account, past El Nino strengths plus the upcoming forecast based on the dynamical models for a strong El Nino in the winter of 23-24, 1991-92 winter comes closest as an analog. And that was a milder than normal winter in the 91-92 winter. Okay? Now, there are some models that are indicating that we potentially could top out and max in strength at the moderate El Nino level. If that were to occur and we don't quite reach the strong criteria for El Nino this upcoming winter, then 2002-2003 winter would be the relevant analog. And that was a colder than normal winter for the eastern U.S. All right, so there's a lot of things I'm factoring into this research. Now, further research can definitely be conducted on this topic. In fact, I plan to take these slides here and further expound upon them in future videos. And I'm going to take into account teleconnections, what those teleconnections were for those particular winter seasons. I'm also going to take a look at the snowfall patterns, the distributions of snowfall above and below normal across the United States. I'm also going to look at the sea surface temperature anomalies outside of El Nino, because those sea surface temperature anomalies tend to change over time across the middle latitude oceans, specifically in the Pacific, North Pacific there. So outside of El Nino, which is generally fairly predictable, I'm going to take a look at the sea surface temperature anomalies. I also want to mention that they change, and they all ultimately, like next month or the month of September, the analog year might be a little bit different than what I'm showing you tonight. Now, specific locations of the warmest sea surface temperatures in the equatorial Pacific, I'm also going to look at that. East Pacific based, where the warmest temperatures are not necessarily in Nino 3.4 region, but closer to the west coast of South America, versus the Central Pacific base, where those warmer than normal waters are much further out towards the Central Equatorial Pacific. That makes a big difference where those locations of the warmest sea surface temperatures occur. It's not necessarily that we have an El Nino, but if I were to break it down further, where do those warmer than normal sea surface temperatures, normal above normal water, where does that occur? So I will be taking a look at that. So this is kind of like my shell, right? I've identified the years in tonight's video and kind of showed you what it looked like. I'm going to expound upon that in future videos, looking at the further research right here. All right, that wraps things up tonight. Hope you enjoyed the video. I really do enjoy doing this research. Trying to choose an analog year for the upcoming winter is never an easy task. Um, there's a lot of research out there on many areas, and you just kind of have to like dig into the areas and see if there's any kind of recognizable similarity between where we stand right now in July 2023 and the past Julys where we had El Nino conditions already in effect. And then go from there and try to identify potential relationships between these El Ninos in the summer season preceding the following winter. So, all right, that wraps things up tonight. Spot on weather. Hope you enjoyed this video. And until next time, everybody, take care and God bless.